issued an air quality health advisory.
The air feels quite heavy.
The worst day of this event.
The worst air qualities for big cities in the
climate emergency killed.
Pollution.
Air pollution.
Air pollution.
Climate change continues to be one of the greatest environmental challenges facing the world today. As greenhouse gas emissions increase, carbon dioxide has become the primary contributor to global warming, affecting ecosystems, weather patterns, and public health. But an important question remains: where are these emissions concentrated, and how can we accurately identify the areas most affected? Let's explore the research titled Spatial Integration of Atmospheric CO2 Concentration and Carbon Emission Inventories for Localized Greenhouse Gas Hotspots Identification using GIS. This study combines atmospheric CO2 measurements with carbon emission inventory data using GIS to pinpoint localized greenhouse gas hotspots. By integrating multiple sources of spatial data, researchers can produce detailed maps that reveal where emissions are most concentrated, providing valuable insight for urban planning, environmental monitoring, and climate action.
Have you ever wondered if the carbon emission data that we use to fight climate change is actually accurate? Right now, cities are trying to cut emission, but they are playing a guessing game because they lack of precise data. Traditionally, we measure carbon in two ways. We use bottom-up statistical inventories, which are highly detailed, or we use top-down satellite data, which show real-time atmospheric CO2 but get drift by the wind, making it hard to find the exact source. This research bridged this gap using Geographic Information System or GIS by spatial integration physical atmospheric CO2 concentration with local emission inventories. We can filter out the atmospheric noise and pinpoint the exact localized greenhouse gas hotspots. Ultimately, this study takes the guesswork out of climate action, allowing urban planners to deploy targeted green policy exactly when they are needed most.
Current studies often analyze atmospheric carbon dioxide, CO2 concentrations, and carbon emission inventories separately, which makes it difficult to verify whether areas with high atmospheric carbon dioxide are directly linked to actual emission sources, reducing the reliability of greenhouse gas hotspot identification. The ground-based monitoring stations are limited in number, while satellite observations are frequently affected by cloud cover, atmospheric conditions, and missing data. These limitations reduce the accuracy of representing the true spatial distribution of atmospheric carbon dioxide (CO2). The combination of sparse monitoring data and uncertainties in spatial interpolation makes it challenging to precisely identify localized greenhouse gas hotspots, particularly in complex urban environments. And although GIS is widely used for environmental mapping, most studies applied it to individual datasets rather than integrating atmospheric CO2 concentrations with carbon emission inventories. This limits its potential to produce comprehensive hotspot maps that can effectively support climate mitigation and environmental planning.
Climate change is driven by increasing greenhouse gas emission, making it essential to develop effective strategies for reducing carbon emission. This study demonstrates how Geographic Information System or GIS can support sustainable environmental planning in Qatar. Qatar aims to reduce its greenhouse gas emission by 25% by 2030. To achieve this goal, researchers combine GIS with the analytic hierarchy process, which is AHP, to identify the most suitable location for solar and wind energy development. GIS integrates multiple spatial data sets, including wind speed, solar irradiance, terrain slope, road, electricity grid, urban areas, and protected areas. Using weight overlay analysis, GIS produces land suitability map while excluding environmentally sensitive and restricted areas. The results show that GIS successfully identified the best location for renewable energy, helping Qatar increasing clean energy production and reduce greenhouse gas emission. So this case study demonstrates that GIS is powerful decision support tool, providing accurate spatial analysis for environmental planning, climate change mitigation, and sustainable development. Transportation is essential for daily life, but it is also one of the largest sources of carbon dioxide emission, contributing to climate change and poor air quality. Traditional methods of monitoring emission are costly and limited. Today, Geographic Information System (GIS) and remote sensing provide faster and more efficient way to monitor and manage environmental issues. A study investigated the spatial and temporal distribution of vehicle-related CO2 emission in Mukim Kajang, Selangor, with objective of identifying emission hotspot and supporting sustainable urban planning. The study used Sentinel-5P, which the satellite carries the tropomic instrument, which continuously monitor atmospheric pollutant across large geographic area. Although Sentinel-5P does not directly measure CO2 at the required local scale, the study estimates CO2 emission using carbon monoxide or CO2 as proxy. Monthly satellite data collect enable continuous monitoring of emission pattern without relying solely on ground-based measurement. After obtaining the satellite data, the researcher analyzed the information using ArcGIS 10.5. Several GIS techniques were applied, including coordinate transformation, raster processing, extract by mass, zonal statistics, and hotspot analysis using greatest ArcGIS method. This analysis transformed raw satellite observation into detailed map showing the spatial distribution of CO2 emission across Mukim Kajang. By combining remote sensing and GIS, researchers can continuously monitor environmental conditions, identify pollution hotspot, and visualize emission patterns through the map. This information enables government and planners to prioritize areas that require immediate intervention. The study recommends promoting public transportation, encouraging electric vehicle adoption, and improving traffic management to reduce dependence on private vehicles and supporting sustainable urban planning to reduce transportation related to CO2 emission.
Hi, my name is Nur Azim Shafina, and I'll explain about the third case study, which is data drought in the humid tropics, how to overcome the cloud barrier in greenhouse gas remote sensing. This study addressed the challenge of monitoring greenhouse gas such as carbon dioxide and methane in tropical rainforest regions like the Amazon. These regions are important because they store large amount of carbon. However, frequent cloud cover, especially during the wet season, block satellite observations. As the result, satellites collect very little greenhouse gas data, making it difficult for scientists to accurately monitor carbon emission to study climate change. The researchers use GIS and remote sensing. Remote sensing satellites such as CO2 and Sentinel-2 were used to collect greenhouse gas and cloud data. GIS was then used to combine and analyze this dataset, helping researchers identify cloud-free areas and improve greenhouse gas mapping. The study found that using higher resolution satellite image around 200 to 400 meters allows satellite to capture data through small gaps between clouds. This significantly increased the amount of usable data and improved the accuracy of greenhouse gas monitoring for better climate change management.
In conclusion, this documentary has explored the application of GIS and remote sensing in identifying localized greenhouse gas hotspots through the integration of atmospheric CO2 concentration data and carbon emission inventories. By reviewing the selected scientific literature, it highlighted the current challenges, the importance of spatial integration, and the role of GIS in supporting climate change mitigation. This emphasized the potential of GIS as a powerful decision support tool for environmental monitoring and climate planning. Overall, this project has strengthened our understanding of environmental applications of GIS and remote sensing, while enhancing our communication and teamwork skills through the production of this documentary.